Hey everyone, it's Tony from Archism. We're on our second projectile motion. Actually, this is actually going to be our first one. It's just the part two of this mini series that we have here. In this video, I'm going to be solving a problem that I made up just symbolically, just going through all the things that were gone over in part one, just figuring out the puzzle as I said in the last video. So let's see what the problem is. I am standing on a level stretch of land and I decide to throw a ball upwards. Not vertically upwards, or not straight up, but up. The ball is in the air for delta t and lands delta x away from me. Based off of this information, I want to know the following in terms of delta x, delta t, and g. So I want to find how fast I can throw, how high I threw, and how fast the ball was going as it hit the ground. So let's get started on part A. So it wants to know how fast I can actually throw. So that just means our velocity. So I'm going to start off just writing down my second cake equations. So delta x is equal to, this delta just means change in x. So the final x position minus the initial x position is equal to our velocity in the x direction, delta t, plus 1/2 ax delta t. And let's not forget our axes and our graph. So let's just draw a little bit of a situation here. So here I am, and I decide that this ball is going to go like this. And let's say it just lands over here. So let's redraw those axes. They didn't seem very straight. So I'm over here, and then I decide to throw this ball right here, and then it lands on the ground over here. And I threw it with some velocity. So it started off going like this. And then this kind of had a velocity in the x direction, and it also had a velocity in the y direction. And then in addition to that, you have your acceleration, your ay, and you know that ay is going to be equal to negative 9.8 meters per second squared, and that your acceleration in the x direction, ax, is going to be equal to 0 meters per second squared. So going back to writing our cake equations, delta y is equal to yf minus y initial is equal to vy delta t plus 1/2 ay delta t. And actually we're going to have this negative 9.8 just be negative g, since we're solving this symbolically. So next, I just want to start off finding the velocity in the x direction, because I think that that's just going to be the most easy. So we know that our change in x position, right? So we have it starting from here. Let's just call this 0, and we have it going to delta x, right? So x final is just going to be equal to delta x. So we're going to have delta x times this is equal to this unknown x velocity. And then we also know that delta t is known, so we can actually use that in solving it. And we also know that this acceleration in the x direction is going to be equal to 0. So actually, let me erase that ax. Oops. Okay. And then we're just going to have 0 delta t squared. So that just eliminates this entire thing. So we don't need any of this. And we know that our delta x, which is just going to be how far the ball traveled, is going to be equal to our velocity in the x direction times delta t. So since we are given both of these things, we know that we're given delta x right here, it lands delta x away, and it stays in the air for delta t. We can find that our velocity in the x direction is just going to be equal to delta x over delta x over delta t, right there. So we've solved part A. So this may come in handy later, but we have our velocity in the x direction right there. So next we have to find our velocity in the y direction. So what we're going to do is we're going to plug in everything that we know. We know that our y, we start at a, let me actually label these, x, and then in our y direction, we're going to be starting at 0, so y initial is going to be equal to 0. But what happens is that since we're starting on the ground and we're also ending on the ground, so our y final is also going to be equal to 0. So we know that our delta y is just going to be equal to 0. So we know that our velocity in the y direction is some quantity or some combination of these variables that we were given. And we also know that our ay is going to be equal to negative g. So it's going to be a little bit more complicated than what we had before, but we'll see what happens. So 0 is going to be equal to 0 is going to be equal to velocity in the y direction, delta t, plus 1/2 negative g delta t. So solving for Vy, we're going to have 0 is equal to Vy delta t plus, or not plus, minus 1/2 g delta t. So solving just negative, we're going to have negatives on both sides, so we're going to have Vy delta t is equal to 1/2 g delta t. Oh, sorry, delta t squared. Can't forget the squared. So dividing delta t by both sides, we're just going to have Vy is equal to 1/2 g delta t. So this right here, we have our velocity in both directions. So if we want to find write that with our unit vectors, all that would be is delta x over delta t I hat plus plus g delta t over 2 j hat. So the reason that both of these are going to be positive because our initial velocity is going to look something like this. I threw it upwards but not vertical, and I also didn't throw it horizontally. I kind of threw it diagonally. So if you see that, you're just going to see, okay, in the x direction we're moving towards the positive x-axis, and we're going to be moving upwards the positive y direction. So we're just going to have this as our final velocity. So I didn't really specify whether we wanted to find magnitude or if we wanted to find it in unit vector form. So I'm just going to quickly find the magnitude of this vector. So v is going to be equal to the square root of delta t, or delta x, over delta t, both of them squared, plus g squared delta t squared for 4. So right here and right here we have our two answers, one which gives the magnitude and the other one which gives it in unit vector form. So moving on to part B, find how high I threw. So if you think about a parabola, or if you think about any object, you can see that, okay, when I'm standing on the ground and I throw it, it's going to peak at some point. So that point is going to be right here. So at this point, since you have that acceleration in the negative y direction, so ay is equal to negative g, the initial velocity that I threw it at is going to be decreasing as it goes, and then it's going to hit 0 right at this point right here, and then it's going to switch to negative. So it's going to be moving in the negative direction from the second half. So in order to find how high I threw, all I need to do is find the delta x when you get Vy equal to 0. So I'm only really going to need one of my equations right here. So I'm just going to call that how high I threw. I'm just going to call it h. So h is equal to Vy delta t plus 1/2 negative g delta t squared. So we know that this term immediately goes out because at that point you're going to have your Vy equal to 0. Let me just label that Vy is equal to 0. And then you're going to have your h as equal to negative 1/2 g delta t squared. Or actually, this is actually not going to be delta t. This is going to be delta t2. But it also happens, delta t2, our second time, also happens to be equal to 1/2 delta t, which is very interesting because this part is half the time and this part is the other half. You can think about this as the graph of a parabola. Its vertex is actually going to cut the parabola in half. So this point right here is going to be your delta t. So if this whole area goes over the span of delta t, right here you're going to be at 0, and then right here you know that you're going to be halfway done with the time. So we're actually going to put that over 2, and our h is going to be equal to 4 times, so negative 1/8 g delta t squared. Okay, moving on to our part C. So we have how fast the ball was going as it hit the ground. So if you watch the part 1 of this mini series, you know that your velocity in the x direction is going to be constant throughout. So if you remember from the first slide, the velocity in the x direction is just going to be equal to delta x over delta t. So the answer to this part C is going to be, you can find it in two ways. You can think about, well, actually I'll go over the second way once I finish the first way. So the only thing that you need to think about right here is the velocity in the y direction, which is what changes. So we can think about it using our third cake equation. So Vf final squared is equal to V initial squared plus 2a delta y. So just to make the symbols a little bit easier, I'm just going to think of it as this second half of the problem. So starting right here, if I was standing right here and I threw something down and it hit the ground over here, what happened in this time? So this delta t over 2, this second half right here. So one thing that you have to remember about using the regular cake equation, you have to convert your thinking back to that regular acceleration. So although it's accelerating downwards towards the negative y direction, you have to think about this in only one dimension. So it goes from 0 to some final velocity, the fastest that's going to go when it's closest to the ground. So that's getting faster. So we're going to have our acceleration actually be equal to positive g. And our initial velocity is going to be equal to 0. So Vi is equal to 0. because right here it reaches the apex, our velocity in the y direction is going to be equal to 0. And our a is equal to g, just g, not negative g. So you have vf squared equal to 2g times our h. So you have your 2gh right here, and you just find the square root of that. So vf is equal to square root of 2gh. So you're ready to find your final velocity. You can think of it in terms of finding that magnitude, which I'm going to do right now. So v final is equal to the square root of delta x squared over delta t squared plus root 2gh squared. And if we go back to our very first problem, you see our velocity right here is going to be delta x squared over delta t, g squared, delta t squared over 4. So finding that, you can see that vf and plugging in our h from our previous problem, which was our, actually this isn't going to be negative because you can't really have negative height. It's just after plugging that in. So the answer to this second one is actually just going to be 1/8 g delta t squared. So plugging in our h, so square root 2g times h, which was 1/8 g delta t squared, so 1/8 g delta t squared. So plugging that in, you just get 1/4 g delta t squared, or 1/4 g squared, the square root of that. That's going to be equal to 1/2 g delta t. So this is going to be pretty interesting because if you look at our original problem, or our velocity right here, it's going to be equal to this right here. So this part on the inside, that because you're going to be squaring this quantity right back in here. So you see that the final velocity is going to be equal to the initial velocity. So the reason that I could have said that at the very beginning is because looking at a parabola, if you find the derivative right here, the slope at that point as the height approaches 0 is going to be the negative of this derivative right here. So it makes sense that the magnitudes of their velocities are going to be the same. But what's different, you see the difference when you put them in unit vector form. So you have your delta x over delta t, constant all the time, so that's just going to be positive I hat. But you're actually going to have negative root, or negative negative 1/2 g root t, not square root, j hat. So that's because you see that if you draw the vector right here, you're going to have velocity in the x direction like this, and you're going to have velocity in the y direction pointing downwards. So you're going to have it moving in the negative j hat direction. So that's why you're gonna it's gonna be slightly different than what we got in our first problem, right there. So I just think that's pretty cool that the velocity at the beginning, the magnitudes are gonna be the same as the magnitude of the velocity at the very end. So that's it right there. This was quite a long video. So please, if you have any questions, if I made anything a little bit confusing, please send the questions to ArchismGroup@gmail.com. Please like this video, subscribe to our channel, and as always, thanks for watching. I'll see you next time.